You did some work in Algebra 1 with parabolas. Not hard ones, but you dealt with some parabolas. Probably the one that you're the most used to when you're talking about shapes of curves and things in parabola, or in Algebra 1, was this guy, right? Kind of the standard, vanilla parabola is the equation y equals x squared, which is a simple parabola with a vertex at the origin that opens upward. Okay? The reason I want to remind you about that, we're going to look at things a little differently with parabolas today, but I want you to remember this part of it. In the quadratic equation whose graph is a parabola, only one of the two variables, x or y, is being squared, but not both, right? Only one. So in a normal parabola, x is being squared. A parabola that opens up or opens down. The parabola could also, if x is being squared, the u could either open up or down, right? That's normal. This is not as normal. You probably didn't see this in Algebra 1, or if you did, it was only very briefly. If you want a parabola where it's tipped over, so the u-shaped parabola opens up to the right or the left, now we're making a change. Now the variable that's being squared is y. That's the one that's not normal. It's unusual, okay? All right, so we want to go one step further than that, though. We want to come up with a standard form equation of a parabola that allows us to easily graph it or identify a graph. So we want to be able to do things like identify the values of parameters that are going to tell us what the parabola looks like. Let's compare this to what we did yesterday, right? Yesterday we looked at if we wanted to identify a circle, either graph a circle or identify the graph of a circle or something like that, we really only needed to know three numbers, three parameters. What were they?
Center, radius, and
Yes, center and radius, and that's it, isn't it? The center tells us, if I know the location of the center point, and the coordinates we just called HK, right? That tells us where the circle is. And then the other part that we could control is how big is the circle, and that's R. All we needed were those three numbers, and that did everything for us, right? We want to do the same kind of thing for parabolas today. Okay, so we're going to start off for a vertical parabola. So that's going to be one that either opens up or opens down. Here's the standard form equation that we're going to use. X minus h squared equals 4p times y minus k. The reason we write it that way is because then the three parameters that we're going to choose, h and k and p, are going to tell us the same kinds of things for a parabola that we had for a circle yesterday. What do you suppose that h and k is probably telling us?
points on the graph.
Okay, it's going to be a point, isn't it? Now, what's going to be the one point on the parabola that's kind of unique that we could? The peak, yeah, which we call the vertex, right? So h and k are going to be the coordinates of the vertex, and p is just going to tell us essentially two things. Does the parabola open in the positive direction or the negative direction, and what's the shape going to be? Is it going to be tall and skinny, or is it going to be kind of compressed and wider? Okay. Here's the picture that we use. When we want to relate these parameters to what the parabola looks like, here's what we do. You might remember, it's been a long time, but we said that a parabola was the locus of points that are equidistant from a line that we call the directrix. You remember this? Oops. There's a line called the directrix and a point called the focus. So if I want to find the set of all points that are, for each point is going to be the same distance from that point and from that line, it's going to create a parabola, right? Remember I made that document in Geometry Sketchpad? Remember seeing that? It's been quite a while, almost a month ago, but hopefully you remember. So it produces, that's the shape that it produces. So for example, the distance from the focus to that point right there should be the same as the distance from that point to the directrix, if I had drawn it correctly. Okay? So the coordinates of the vertex, we call that V for vertex, the coordinates are just going to be h and k. And what P does, P is the distance from the vertex to the focus. So that distance right there is P. So if P is positive, that means that the focus is above the vertex, and that means the parabola is going to open up, because the parabola always opens to swallow the focus, right? It's going to open away from the directrix and surround the focus, okay? So if the focus were down here, for example, the vertex would be in the middle, and the parabola would be doing that instead, and in this case, P would be pointing in the negative direction, so P would be negative. Okay, see the difference? All right. So then our goal is, we want to be able to, if we're given, for example, the first thing we're going to do, if we're given the coordinates of the focus and we're given the equation of the directrix, can we come up with the parabola that fits that information? Okay? So let's try one like this, right? I think, at least at the beginning, I think it's going to be a good idea to maybe even sketch these things when you're doing the problems in your notes. So let's start off with the directrix. The directrix is the line y equals -5. So we've got to review something here. When you have a line like that, where it's y equals a number, what can you tell me about that line? It's going to be what? It's y is negative, but what's the line look like? It wasn't a very clear question, probably. What's that line going to look like? It's going to be straight. Well, all lines are straight, but what's beyond that? Where is it, horizontal or vertical in this case? It's horizontal, and the reason it's horizontal, if you're not sure, and those are things that it's easy to forget. Here's a way you can remember that. It's not just a fact, but it's something that'll sink in a little deeper. You can always think about, if you have a line that's either x equals a number or y equals a number, we know those are the oddball ones that are horizontal and vertical, right? Which one is which? Well, this is essentially telling you where the line cuts through an axis. So it's cutting through the y-axis at -5. Well, if it's cutting through the y-axis, that's the vertical axis, the line must be horizontal, right? Because a vertical line would just be parallel to the y-axis. Does that make sense? So this has got to be horizontal. So here's our directrix. And what about the focus now? Is the focus, all we need to know is the focus going to be above or below the directrix? It could be above. How come? How'd you know? Because what?
Because that one is negative and then one positive.
Yeah, okay. And which is the one that's really important? Which coordinate's really the one that's important here? The y coordinate, so the 3. Good. So 3 is bigger than -5, so the focus is going to be above the directrix. We don't have to, put an x, y. You don't have to draw the x and y axes. That's not important, really. That'll just confuse you. Don't even bother with that stuff. We just need to know we've got some representative point that's our focus, and we've got the directrix, which has the equation y equals -5. Now, visually, where does the vertex have to go? I mean, you don't have to be real precise mathematically yet. Just tell me, where am I going to make my dot on the board?
Middle.
In the middle, right? It's got to be halfway in between the focus and the directrix. So it's got to be, about there, right? Something like that. Okay? So that's my vertex. And we need to know two things. In order for us to come up with, and really all we want to do is be able to just fill in the parameters. We want to be able to, we want to write the simplified standard form equation. So we need to know the values of h and k and p from our little sketch, and then plug those into the standard form. See if you remember the standard form. What did it look like? X minus h squared equals 4p times. Good, and all we got to be able to do is just plug in values for those 3 numbers, and we're done, right? So h and k are the coordinates of the vertex. We need to be able to find the vertex thing, right? So what are the coordinates going to be of that vertex and why? Whoops. One of the coordinates is just a gimme. Notice how, if this is a vertical parabola, notice how the vertex and the focus are lined up.
3. It's going to be the same one.
Which one? Okay, I heard a 3 and a 2. How come 2? Okay, good, because it's lined up vertically, isn't it? Good. These are lined up vertically, and so that means that they both must be scooted over from the origin the same amount horizontally, right? They have the same x value. Good. So we know right away, before we even think about anything else, we know that the x coordinate is 2. Always going to be the same for a vertical parabola. Now, you already told me visually that the vertex had to be in the middle. So now the other thing I've got to do, which is just a little bit more work, is I've got to figure out what's the middle y value. Okay, and let's actually talk about that for a second, because there's a really efficient way to do this. There's a lot of ways you could think about this, and I'm not going to pretend that anything's wrong. If it gets you the right answer, then at some level it's right, but there is a really efficient way. Before we do anything, though, just tell me what the answer is. Think about it for a second. What's the y value of the vertex? And it's probably important for us to look at those y values, isn't it? Not quite. Close. What's it going to be? Okay, you're thinking because that's half of 3, right? Okay, but really remember that this isn't the x-axis, right? This is the directrix. So the x-axis might be, it might be up here somewhere, right? See what I'm saying? So really it's not, that value by itself isn't so important, but remember that the y value of the vertex has to be the middle value of these two y values, because it's got to be halfway in between, doesn't it?
Is it 2?
So it's, no,
Negative 2?
close. No. What's the middle number from between 3 and negative 5?
It's a 4.
What is it? It's negative 1. How'd you get that? Okay, and so one way you could do it, so were you thinking they're 8 apart? They're 8 apart, and so it's got to be 4 away from both of them, right? So we could say, okay, well, if from negative 5 to 3 is a distance of 8, then this has got to be 4, and whoops, and this has to be 4. Take your pick. We could either add 4 to negative 5 or subtract 4 from 3. Either way, we're going to get negative 1. Okay, there's a trick for this, though. There's something you guys have been doing for a long time that does this more easily. Finding a middle value. Let's say, for example, let's say that on one test you got an 82%, and on one test you got 100. What's your average test score? Isn't that just the middle value? That's just the middle of the two, isn't it? How would you get the average there? You add them and then divide by 2. Yeah. That's called a mean or an average, right? And that's really all that does. If you calculate a mean of 2 numbers, you're calculating the middle value, right? So there's an easier way to do this. How could I take these 2 numbers and quickly come up with the value negative 1? The mean of 3 and negative 5, same recipe, add them up. What's 3 plus negative 5? Negative 2 divided by 2 is negative 1. Got that? Okay. Make sense? Okay. And then the last thing we need is, okay, so to go from the vertex to the focus, there's the arrow. How far away is it? From negative 1 up to 3 is moving how far? 4. So that's telling us that P equals positive 4. We've got everything we need, right? Because this is H, that's K, and P is 4. All I got to do is plug that stuff in and we're done, right? So we're plugging in an H value of 2, a P value of 4, and a K value of negative 1. What do I get if I do that? X minus 2 squared equals, what's that number going to be? 16. 4 times 4 is 16 times y plus minus negative makes it a plus 1. That's it. That's my answer in Moodle. Okay, that's the form we wanted in. It looks kind of goofy. Why do we want it in that form? Why wouldn't we distribute the 16? Because that ruins it. If we leave it in this form, we can always say, okay, well, there's H. H is 2. K is negative 1. And 16 divided by 4 is 4, so P is 4, right? See how nice that is? If we can just inspect that equation and get all of the values we need to graph this thing, right? Does that make sense? Okay, We'll try something different here. Get your Chromebook real quick. Go to the 4.2 assignment, and I want you to do number, I'll tell you, I think it's number 2. So you're actually doing part of your assignment now. What's that? Yeah.
Someone smells like red tacos.
This guy right here.
So go to the 4.2 practice 1. We're going to get some of your homework out of the way now. And I want you to go to problem number 2. Okay, and I want you to do problem number 2. Everyone's is going to be a little bit different, but I want to see if we can get a good answer on this one.